4.2 is very specifically on perpendicular bisectors. You're going to have problems that deal with perpendicular bisectors, and you're going to have to know about something called the circumcenter, which is created by perpendicular bisectors, which we'll talk about in just a little bit. But the first thing that we need to know is that a perpendicular bisectors could be anything. It could be a line, a segment, or a ray that is perpendicular to the segment at its midpoint. Meaning this: if I have a segment that has something going through its midpoint, like this thing's going through the midpoint D, and it creates these two congruent pieces. AD is congruent to DB. That's definitely a midpoint. It's being bisected by CD, and it's a right angle. Then every single point from point C to the end point is going to be congruent from point C to the end point A. These two distances are also going to be the same. If I think about it, it's like going to crash. Don't worry, it'll crash and then come back, I think. Wrong section. This section. Back. Great. Not a perfect recording, but that's how it goes sometimes. So the distance from here to here and the distance from the same point to the other end point will be the same. These are going to be congruent to each other. And if you wonder why, like why would anything be the same, it's because you have a side and an angle, and that reflexive side, the one that's shared, is going to be the same in both. Meaning the hypotenuses will have to be the same as well. And I could have a point over here like C2 or C3, and all these points would be equidistant as well. That's what's kind of neat about the perpendicular bisectors, is that you get these perfect triangles that are congruent to each other. Your worksheet that I just passed out to you has a variety of questions, and some of the questions are going to come from 4.1a. They're going to ask you, what's the distance formula? What's the midpoint formula? What's the slope formula? And you're going to need to know what those are. If you can do it from memory, that'd be great, meaning you have it memorized. I would recommend you try doing it from memory first. If you can't remember what those three formulas are, they are in 4.1a notes. You can use those to find the formulas. For example, I know what the distance formula is. It's the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. If you don't remember that, you're going to need to use your notes. I hope you know how to find the midpoint, and I hope you know how to find the slope. It's there. Your worksheet's also going to see if you know what these two words mean, the word concurrent and the words point of concurrency. The word concurrent means when all three lines meet at one point. There are several things about triangles that are concurrent. You're going to learn a word in 4.2 that the perpendicular bisectors of a triangle's sides are all concurrent. Same with their angle bisectors, same with their altitudes, and same with their, what's the last one? I can't remember, but there's four of them. And the word concurrent means all three meet at one point. Where they meet is called the point of concurrency. For example, if I look at the perpendicular bisector of this side, that line, that perpendicular bisector goes forever and ever this way. This perpendicular bisector goes forever and ever this way. This perpendicular bisector goes forever and ever up and down this way, but they all meet at one point. That one point is called the point of concurrency. Where does it, where are all three lines meeting? It's right here. That has a specific name. That name is the circumcenter. It's one of the coolest things that you will ever get to play around with triangles and circles. It is the exact center point that if you were to draw a circle, it will go exactly through the three corners of the triangle. And what you're going to get a chance to do today is you're going to get a chance to actually draw and see a triangle that circle that goes through all three corners of the triangle. And that's what we're going to do. The circumcenter is created from the intersection of the perpendicular bisectors of each side. So this side's perpendicular bisector, and this side's perpendicular bisector, and this side's perpendicular bisector meet here at this point of concurrency, and that is called the circumcenter, which is kind of neat because in real life, a really good carpenter is going to use this. If you've ever wondered, like, hey, why we learn this stuff anyways, think about a doorway. And the doorway, sometimes you have doors and no doors in a hall, and we get rid of the doorway and we have this thing like this. And I don't know if you've ever been to a Spanish-style house, but they have these things that are called arches, I guess, like that's what you would say. Their doorway's an arch. It's in the Pueblo style of a house. I don't know if you've seen something like that. But if you've ever wondered, like, how would you know how to make a perfect circle, a perfect arch, you could use this. A good carpenter will know that there's this point, that there's this point, and then there's this point, and those three things need to be the same. They need the perpendicular bisector of this piece, and they need the perpendicular bisector of this piece, and the perpendicular bisector of this piece, and guess what? They could find the exact center point to be able to make a perfect circular arch. Then again, you might hire the guy who just goes, and it might look like this. You never know. But if you have a really good carpenter, they're going to know their geometry, and they'll be able to do that if that's something you want in your future. Okay, so how are you going to figure out where those things are? I have 5 rules or 5 steps that you're going to probably want to follow. You may or may not want to write this down. It's up to you. I will come back to it in just a second. So I have 5 steps. I know I didn't have you guys write that down. So instead, let's jump to an example. This is number 9 on your worksheet. If you want to turn to your worksheet now, take a look at it. Question A says, from the information given, how is TV related to SU? How is segment TV related to segment SU? How are these two things related? They are what with each other? Do you know? If you know, say it out loud. I heard perpendicular bisectors, which is what you want. TV is the perpendicular bisector of SU. I don't like to write out the word perpendicular. You can if you want to, but I use the symbol. The upside down T is the symbol for perpendicular. Then they're going to ask you a bunch of common sense questions based off of what I've taught you so far. TS. How long is TS? And remember, this is a perpendicular bisector, which means that the point T is equidistant from the endpoints. I bet you know how long TS is using common sense. If you know how long it is, say how long it is out loud. I agree. It has to be. They're equidistant. Find UV. It doesn't matter if the perpendicular bisector goes through the top or it goes through the bottom. Guess what? The two sides are always going to be equidistant from the endpoints. So I bet you know what UV is going to be. If you know it, say it out loud. I agree. I'm going to use 3 and 3 because I've already used 2 and 2 up there. They have to be equidistant. Lastly, SU. They've given you RU's length. There's a little arrow that says RU is 3 units long. So SU has to be how long? A 3 and another 3 together makes 6. Awesome. And a lot of the problems are just going to be dealing, do you know that things are the same distances on both sides? That's what this shape is. It's a kite. It's the top is the same on this side and this side. The bottom is the same as this side and this side. So the last thing that I have for you is number 14. And number 14 says, where should the farmer place the hay bale so that it is equidistant from the 3 gates? What that means is if you have a triangle and there's 3 points and you want to be equidistant from each of these, you need to find the circumcenter. How do you find the circumcenter? The first thing that you do is you figure out where is the perpendicular bisectors of both sides. You're going to probably need a protractor for that. And then you'll do that for multiple sides. So that's what I'm going to do here. I'm going to pick a side, and I'm going to figure out where the midpoint is. And this is probably the easiest side to start with, this side here. From this point to this point. On number 14, do you know where the midpoint is? Is it at 0? I agree. Do you know where 90 degrees is from that point? If this is my protractor, let me show it to you, and I set this hole right where that midpoint is, do you know that 90 degrees is just straight up and down? Like, that's the goal. If you know that, then what you can do is you can draw a line. I'm going to use this red line here. Well, let me try to see if I can do that again. That did not like that, did it? There it goes. There's my perpendicular bisector. Oh, I didn't want to move it. I wanted it right there. Over here. 90 degrees. There's my first perpendicular bisector of one side. Now this is where it gets a little bit harder, because these diagonals, you can't just count how many squares because it's a diagonal. So what I'm going to recommend that you do is I'm going to recommend that you use a ruler, and you use the metric side of a ruler to measure it to find the midpoint. The easiest way for me to find a midpoint of something, let me center this over here, there you go, is I go and I put the 0 centimeters there, and I see how long it is, and I just measure it. So right now I'm measuring this as 4.8 centimeters. That's why I like centimeters, because it has decimals that are in the tenths. What's half of 4.8? 2.4? So then I go over, 2.4 is right about here. That's the midpoint. Then I can take my protractor and I can figure out where 90 degrees from there is. So here is my protractor. I can set this right over it. I can make sure 0 and 0 line up, and 90 degrees is, I'm going to put a little dot right here at 90 degrees. Then all I have to do is take my ruler and draw my other line. So instead of my ruler, I'm going to use this fancy one. And guess what? This is now my perpendicular bisector of this side. Let me show you those steps again, but this time I'm going to do it on this other side. I'm going to measure it. It's 0. I measure this side, 4.8. Half of 4.8 is 2.4, right there. Once you get that midpoint, that's the midpoint, you take a protractor You put that right over it. You figure out where 90 degrees is. Don't assume it goes through the vertex of the other triangle. Once you get that, you take your ruler, you make your point, and what do you know? All three perpendicular bisectors intersect at one point. They are all concurrent to each other. What is this point? This point is called the circumcenter. It's the exact center point that's equidistant from the three corners. And what's really neat about this, I don't know if I can do it with this, but I'm going to try. I can take a compass. If this really is the circumcenter, I can adjust the compass to that corner, tighten up my compass. I can take my thing, and then I can make a circle with my compass, and if I'm right, it should go through all of these thingamabobs, but I'm hitting something right there. Let me move. There we go. Let's try that. Is that the exact center place where I can go through all three things? How cool is that? I think it's cool. I mean, I think it's one of the neatest mathematical things that you guys get to learn in this class. Okay, so I'm going to end your notes right there, but if you want to have the steps of what I just showed you, there are the 5 steps. Otherwise, I'm going to give you 15 minutes to get that worksheet done.